if I were to ask you who invented or who discovered Pythagoras' theorem, you'd probably say this guy here. This guy here, Pythagoras, from circa 570 to circa 495 before the Common Era BCE. And you would probably be wrong. Although, just because he didn't invent it, it's not that he didn't live an important life, a really, really interesting life actually. But essentially here is Pythagoras' theorem. This side squared plus this side squared gives us this side squared. So in other words, if we get this area that results from this square, add it to the area of this square, it's going to be equal to the area of this square. If this side, this side, this side, and this side are the same length, this side, this side, this side, and this side are the same length, and lastly, these little sides here are all the same length, so that's a square, that's a square, that's a square. They're going to be joined algebraically using this little formula. And it's a really, really important formula. It's just that Pythagoras just didn't probably invent it. So, what are some things that we can see straight away when we have a right angle triangle? Well, the most obvious is this right angle here, and the right angle is just really a symbol for 90 degrees. That means that this angle here and this angle here because there's 180 degrees in all triangles, internal angles, these must add to 90 degrees. So in other words, if this one is 45 degrees, this one must also be 45 degrees. And so on. It's just a really quick shorthand. So, what are these called? I'm going to just delete the writing in this and the writing in this, because I want to give them their most common names. Most commonly, one of the angles is called theta, the Greek letter theta. And it's just the common name that we give to an unknown angle, most particularly in trigonometry. This one often doesn't have a name, but it is quite commonly called gamma, which is kind of like a little curly Y. Not so important. The side here, the side which is adjacent, meaning next to, So if you said, where do you live? I live adjacent to the fire station. That would mean that you live next to the fire station. Adjacent is next to both the right angle and the theta angle. So that's why we call it the adjacent angle. The adjacent side, I should say. This side here is called the opposite side because it is opposite the theta angle. That's why it's called the opposite side. And this last side that gives students all sorts of trouble remembering is called the hypotenuse side. It's Greek for stretched out. And if you sort of picture someone holding a rubber band there and the other end of the rubber band there, stretching them between the two along the longest side, that would be hypotenuse. Sometimes people think of hippos. Hippos are really, really big. Longest side. Hypotenuse is obviously longer. It's got more letters than adjacent and opposite. It's a long word. So they remember it any number of ways. But as long as you remember that the adjacent side is adjacent because it is next to both the theta angle and the right angle. The opposite angle is named the opposite angle because it is opposite the theta. The opposite is right across from that side. So far, so good. Welcome back. Let's do a few examples. Pretty easy examples. So I've got a right angle triangle. I know that this is a right angle triangle. It tells me whenever I have that square there, I know that it's 90-degree angle. The two shorter sides are 4 centimeters and 3 centimeters, and I want to work out how long this longest side is. Well, a squared plus b squared equals c squared. A squared, a in this case is 3 squared plus 4 squared equals, and it's not c, we're told that it's x squared. Okay, so far so good. It's now no longer a geometry question, trigonometry question. It's now an algebra question. So 3 squared, 3 times 3 is 9, plus 4 times 4, 4 squared is 16, equals x squared. 9 plus 16 is 25. Now what do? We want to get rid of this squared. Well, if you remember, if we take the square root of both sides, it gets rid of the 2 there. So the square root of x squared is x. The square root of 25, you should know it, 5 times 5 is 25, so therefore the square root of 25 is 5. It's also negative 5, but obviously distances cannot have negative values. So x is 5, but remember 5 what? 5 elephants, 5 donuts. It's 5 centimeters. So far, so good. Now we want to know the area. What's the area of this right angle triangle? Well, right angle triangles are really easy to find the area. The area is half the base times the height, but recognize that the base is already given and the height is already given as 4. So half the base times the height, so half times 3 times 4 is 6. 3 times 4 is 12 centimeters square. So a good rule is the area of a right angle triangle is equal to half times the two shorter sides multiplied together. Easy. The perimeter, of course, is going to be adding all of those up, so it's going to be 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is 12 centimeters, not 12 centimeters squared, but just 12 centimeters because it's a distance, and centimeters squared is a area.